Good morning, students. How are you all? Fine. Okay, today we are going to start our topic by the topic thermal decomposition, where we have stopped yesterday. Okay, one important thing I am going to ask to you. Yesterday I have given few questions. Did you revise? I hope that you have already learned. Okay, yesterday I told you we'll start next section by an interesting activity which are related to thermal decomposition. All of you, please take page number 4. All those who have the book, please take page number 4. Others, carefully listen the video. Okay, students, here is an arrangement to conduct our activity. Okay, just observe the diagram. Okay, now we are going to start our activity. Place 2 wooden blocks at the same height in front of a wall. See, the diagram you can see 2 wooden blocks. Place 2 wooden blocks of the same height in front of a wall. Place a metal rod on the blocks in such a way that one end of it is fixed to the wall. You see, one end of the iron rod that is fixed to the wall. Attach a paper pointer to a round pencil. Attach a paper pointer. And then place the pencil below the free end of the rod. Heat the rod. You can observe that the rod expands and the pencil rotates, and so does the pointer. This activity shows that the iron rod that expands due to heating, means iron rod got the thermal expansion. Then our second activity, that is fix a transparent straw to a narrow mouthed bottle filled with colored water to the brim. See, here is given the diagram in our book. Please observe the diagram for the arrangement. Okay, this arrangement you have to do. Okay, this is the arrangement. Okay, now we can discuss about the activity. Fix a transparent straw to a narrow mouthed bottle filled with colored water to the brim. Then seal the mouth with a sealing paste, say M-seal. By M-seal also we can do. Now place the bottle in a bowl of hot water. You can observe that the level of the water in the straw expands because of being heated. Take out the bottle and allow it to cool. You can see that the water level in the straw falls as water contracts on being cooled. So, by this activity, we can prove that by heating, liquids also expanding. Another one, the activity related to air. You see, all like balloons. And you can do this activity at home itself. Try to do. Okay. Fit an inflated balloon to the mouth of the bottle. Place the bottle in a pan containing water and heat it. The balloon gets inflated as the air in the bottle expands. The balloon gets inflated as the air in the bottle expands. Remove the bottle and allow it to cool. The balloon gets deflated as the air in the bottle contracts. So this activity shows that air also expanding due to the increase of temperature by heating. That is also because of thermal expansion. Okay, now our topic is change in state of matter. Like water, the substances also change their states on being heated or cooled to the right degree. The change in state of matter from one to another is called interconversion of state. Please underline the change in state of matter from one to another is called interconversion of state. First of all, we are going to discuss about solid-liquid interconversion. Solid to liquid interconversion. On being heated to a particular temperature, a solid changes to corresponding liquid. A solid changes to the corresponding liquid. This is called the melting of solid. This is called the melting of solid. In a solid, the molecules vibrate about their mean positions. It cannot move from one place to another, but the molecules present in solid substances vibrate about their mean positions. On being heated, they receive energy from outside and vibrate with a greater energy than before. Gradually, they receive so much energy that they can overcome the strong cohesion of the solid. I told you, in between the molecule, yesterday we have discussed, in between the molecule there is a force of attraction that is called the intermolecular force of attraction. Another name is cohesion. Gradually, these molecules, the solid molecules, receive so much energy that they can overcome the strong cohesion of the liquid. As a result, the molecules become labile and the solid melts down. The temperature at which a solid melts is known as its melting point. It's an important point, please mark it. Melting point. The temperature at which a solid melts is known as its melting point. For example, ice melts at 0 degrees Celsius, carbon at 3550 degrees Celsius, aluminium at 660 degrees Celsius, and iron at 1535 degrees Celsius. Okay. On being cooled, a liquid changes into the corresponding solid at a temperature called freezing point. Now, another definition for is freezing point. What it is? Once again, on being cooled, a liquid changes into the corresponding liquid at a temperature called freezing point. The change in the state from liquid to solid is known as freezing. When a liquid is cooled, its molecules lose energy and move nearer each other. When a liquid is cooled, the molecules lose energy and move nearer each other. As a result, the cohesion increases, intermolecular force of attraction increases, and the liquid solidifies. That is called a freezes. Interestingly, the freezing point of liquid is the same as the melting point of the corresponding liquid. Freezing point and melting point of the liquid, that is same. Thus, water freezes at 0 degree Celsius. As ice melts at 0 degrees Celsius, both ice and water exist together at this temperature. This also implies that a substance will exist in the solid state only below and in the liquid state only above its melting point. Thus, substances ordinarily existing as solids, example carbon, aluminium, iron, gold, etc., have melting points higher than room temperature. Similarly, substances ordinarily existing as liquids have melting points lower than room temperature. Okay, we are going to wind up today's portion, and tomorrow we'll come back by the topic liquid gas interconversion. Okay, students, it's a time to say goodbye for this section. Tomorrow we'll come back by the next video. Till then, goodbye.